Manny Robles is the Vice President of Sales and Marketing at Sensors, Inc., with over 30 years of experience in science-based business leadership. Holding a degree in chemistry, Manny has excelled in various operational and sales roles, contributing significantly to the company's growth and success. Outside of work, Manny is a devoted family man, enjoying life with his wife and 5 children, an adventurous spirit. Manny is also a licensed sea captain navigating on Lake Michigan, adding a touch of playfulness to his life as he shares his home with 3 lively miniature attack poodles. And so Manny will tag team along with our very own Sean Epps. And so Sean Epps is our business development manager of Heath's GHG Emissions Management Technology and Services, has a decade of experience in EPA-approved direct measurement methods. Today, he consults with clients to help prioritize their methane emission asset management programs through advanced leak detection and measurement using EPA, DOE, carbon registry-approved methodologies with systems such as the RMLDCS, the IC Gas, OGI, and what we're going to hear about here, the Semtech Hi-Flow. Sean is passionate about work and the people that he works with. And so I'll turn it over to these 2 gentlemen to discuss the Semtech Hi-Flow 2 quantification device, and then he's also going to talk about some of the regulations we did yesterday on quantification of grade 2 and grade 3 leaks. There's some conceptual ideas there as well. So with
Great.
that, Manny.
Thank you. Excellent. And let's see, just right and left. There we go. Okay, thank you so much. I appreciate everyone putting up with my sense of humor with the attack poodles, but there are actual stories I can avail you of in the future if you'd like. But today we're going to tag team a little bit. Sean and I were going to go through this. And when you think of sensors, you have to go back. I know Heath goes back 91 years now, right? 91 almost. And we go back about 55 years. And for us, we've launched our whole company 55 years ago based on the need to improve the air that we all breathe, and we take that very seriously. We're in a hub of innovation in Ann Arbor, Michigan. U of M, I'm partial to that. I know there's lots of people that support their own school, but definitely a hub of innovation. And with that, we worked with the EPA to develop our company and go into automotive. And at the time, cars were, just gross emitters, as we all know, as we all saw growing up. I know I did growing up in Southern California with all the smog. So from that, with the Clean Air Act, we helped the EPA, we helped the automotive industry develop, if everyone recalls, the ideals of the Olympics, Citius, Altius, Fortius, higher, faster, stronger. Really, for us, it's lighter, faster, stronger. So all of our product that you'll see, for what we do, it's the most durable, it's fastest, ease of use, and it's lightest for what it does. So that's really what we like to promote and what our ideals in our product. So people have seen, you guys have seen the Hi-Flow 2 over on the table there. It's really a platform of products. So for us, we look at this as a way to solve a problem, primarily with Heath, especially as a great distributor and partner of ours. So we're looking at bringing this technology as a platform. So everyone recognizes the Ghostbuster type apparatus. You have the backpack on the back. You have the handheld portion, and you don't cross streams, right? But with that, we're actually looking to go bigger. So if you see the very top, we'll show you a better picture of that. So we could go all the way up to 300 CFM. And that's with IS as well. And then you have the handheld, and then you have the mini, which is pretty interesting because if you're looking at pipeline, if you're looking at different applications where maybe you don't need 35 CFM, maybe you could get away with 15 CFM as far as your collection, that's where you want to be. you'll be able to go lighter, faster, stronger. So with that, we're very excited about that. And then we also have some other accessories, as you could see, up on the right. So this is really the analyzer inside a environmental box on a tripod. Very simple, but very effective, and also powered by an external battery, which you don't see there. Cellular data and geofencing, which we'll get into. So, we're already, we've mentioned Quad OB here, throughout this summit, and we're already there. We're already developing. We're already going that way. And I'm going to turn it over to Sean right here.
Thank you, Manny. Appreciate it. Well, I'm going to dig into the environmental regulatory part of this. So I have been involved with Subpart W and as a measurement specialist, how I started out in the industry. And a lot has changed since we first introduced the first generation Hi-Flow sampler. And I would like to reiterate what Roy Massengale was talking about earlier about all these regulations that are interwoven together now, and they're referencing each other, and there's about empirical data, and then they're going back and forth referencing each other's regulations. Well, this is a little bit deeper dive into Quad OB, NSPS, New Source Performance Standard requirements for EPA's Quad OB. That is basically subject to certain facilities. However, they're getting into some very critical requirements for the high-flow sampling instrument, which is the main direct measurement tool that is referenced throughout a lot of the EPA regulations. I'm here to tell you that the Semtech Hi-Flow 2 meets and exceeds all those requirements. And so this is just, if we look into it, we have two measurement devices. You have essentially, like Manny said, you have a platform. You have your analyzer module, and then you have a flow meter. In order to quantify leak rate, we're not doing any modeling or algorithms with this type of, it's actually very simple math. All we're really doing is things, basic meteorology 101, except we're using this portable device to be able to quantify unconventional sources like fugitive emissions and leaks. So EPA Quad OB, one of the things first that talks about is gas linearity on your analyzer. Based on some empirical testing that we've done, particularly this data is off of CSU that was captured at Colorado State University. The Semtech Hi-Flow 2 analyzer meets all the linearity requirements across 4 orders of magnitude. If we keep going here, we have the gas interference part here. You cannot have, for Quad OB quantification device, you have to have basically a methane-specific technology. So that basically, honestly, the only thing I can think of is a TDL or a TDLES technology you're familiar with. Because with that type of laser technology, you have a very narrow bandwidth that does not have cross-interference from other gases. And we demonstrate that again through some of the empirical data that's been collected at CSU. Also, interestingly, the particular bench that Manny and Sensors uses actually has ethane measurement capabilities as well. But there's no cross-sensitivity to ethane. It separately measures ethane and methane separately. And in this example, they introduced 400 ppm of ethane, but does not have any interference. It's within the 2.5% requirements the EPA requires. Very difficult to get that with lower cost, other types of sensor technology out there, but easy to do with a good quality laser bench like this. What that really means is that the back rack, the first generation, is obsolete completely just on that alone. And really, from right now, this is you have to have that type of technology in here. So the further, there you go. So this little area here, we have a document certifies that Semtech Hi-Flow 2 meets the compliance specifications of 40 CFR Part 60, Subpart WB. We did the same thing with the OGI camera years ago for Quad OA, because Quad OA had specific OGI requirements, made a compliance statement. We're making a compliance statement here from the manufacturer that states we meet the analyzer certifications for the EPA Quad OB. Flow meter. They also get into not only an analyzer, but you have to make sure that your flow meter is calibrated at least annually. The analyzer, Roy mentioned earlier too, you have to do about, at minimum, do a semi-annual linearity verification check. But the flow meter can be done annually. But the particular averaging pitot meter that they put in the handheld, they're using industry standards to calibrate it, using laminar flow elements, and they're able to demonstrate accurate linearity across the flow meter capabilities. Again, we'll put another compliance statement in there about that and referencing back to the compliance requirements. Background, or actually lower detection level here, or what we call your lower detection limit. This actually goes into, we're about 50 times, 100 times more sensitive compared to a catalytic bead oxidation sensor, because we're using a laser. We're able to see ambient background around the 2 parts per million volume level, so we're able to quantify, anything above background. So we're able to quantify anything above 0, basically. So what that means is that we can quantify far lower than a gram per hour, which is also pretty critical for DOI and American Carbon Registry. Some of these carbon registry requirements where you're having to go out and you have to establish a background of 0 before you go and you do your measurement for carbon for carbon credits, basically, for plugging wells, for example. Another thing too is because it's, again, a laser, you have to have a signal to noise criteria for Quad OB of within 2 parts per million volume. Well, within that criteria of background of, which, 1.5, 2 parts per million, just roughly, that's about how much ambient background methane there is. But we have very little drift on the analyzer. At 0, it's about 0.2 ppm drift. At when we introduce gas, still doesn't drift much, and that can be seen throughout measurements too, that there's very little drift. So if you actually include that drift, we're also accounting for the high-flow samplers operating at the same time. So even with the high-flow sampler operating in combination with the analyzer, the handheld, still very little drift. So we can get very accurate with it. And also compared to, again, the legacy unit, it's a lot more powerful. So some of the limitations too were on the back rack legacy unit, we had limit up to about 10.5 cubic feet per minute, max sampling capability. Now in the new amend rules, both in subpart W and Quad OB, you can't exceed, you can only, your max measurable leak rate is only 70% of your highest capturing rate, sampling rate. So with 35, or our highest max measurable leak rate is 25 CFM, cubic feet per minute, which pretty much covers a lot of what's out there. And that basically sums up the Quad OB requirements, which, because everything's getting interwoven, we really believe it's probably just going to become the industry standard for whatever application you're doing, whether it's Quad OB or not, because of all this going back and forth of regulations that are getting tied in together. Thanks, Manny.
Thank you, Sean.
Let's take it from here.
All right, so ACR. Yeah, many of you may not be involved with plugging orphan and abandoned wells. Being Native American, I'm pretty sensitive to it and a big fan of it, and glad that we're doing that and offering that technology to do that. So ACR has a very strict test method in order to ensure that what you are testing is actually, you could claim that credit. And not only that, some of the downfalls of previous equipment was lack of traceability. So really an audit platform, auditable platform, which is something that we have. Beyond that, in order to meet these new stringent requirements, we're actually helping to develop and proposing test methods for to ensure that this testing is performed correctly. And what does that do? Yes, it does increase battery life. There's some benefits. You're not being exposed to sour gas, but what we're doing is we're taking, okay, yes, it's an instrument that you're testing. What could we do with test scripts? What could we do with automated software? We're looking at, ease of use. We're not, doctoral level science, individuals to run everything. We want to make it a repeatable test, no matter who's running it. And with that, through the test scripts, we are able to do that with ACR and Quad OB. So some of the things that we're offering is, being able to go through a test script and, basically hit start, let it sit, and you saw the, and you could do this in many different applications. You saw the environmental enclosure box with the tripod. You can essentially hit start, and over a 2-hour period, you could go through and perform this testing. This is a screenshot of what it looks live on your tablet, on your phone. You could connect to, and if you guys would like a demonstration, Sean could show you, I could show you. You could connect right to the unit with any web-based device. And that's a screenshot of what that is there. And then at the end, you'll see, what's actually, tested, and it's all testing for stability. There's a picture of Sean there, but really, you could see in real time the leak rates, concentration, flow rate. And another thing that we've developed from a software standpoint is geofencing. There's a little snapshot of, or a picture of what Sean put together, and in one use case, a demonstration that he did.
Quantifying a distribution main, just it's venting the atmosphere.
One thing, and of course, I come from automotive, and in the last year or so, I've been exposed to y'all and the oil and gas, and I have never seen a group of individuals more resourceful, going to a Home Depot and getting everything you need for a certain test to make it work. And the case in point right here. This is fantastic. So with the geofencing, you're able to set a geofence as you would, right? And then go back and over time perform tests, and those would be essentially auditable. Those would be tracked within that region. So it could be a circular geofence, or in this case, an island. It could be, you could freehand it as far as using a polygon, and that's something that we're very proud of. And each with the new latest version. Each analyzer has a copy of the world. So you're not going out and you're not using data to stream down what that map looks like. It's already on there. Latitude, longitude for the entire world is on there. And you're referencing from there. We're not just stopping with ACR. I mentioned Quad OB before. We're developing these test scripts so that way users your technicians would be able to use this in the field. We're actually already using, as far as our end-of-line testing through production, we're actually using linearity checks, accuracy, noise, and so on. We're using that as part of our end-of-line. And, other improvements, calibration certs and so on, Wi-Fi networking. You saw earlier on that one slide that we have, 5G capability that's coming online. And, our calibration that Sean mentioned earlier, this is the test apparatus is for our calibration of the pitot tube, of the flow meter.
CGI, how you have a calibration reminder or alert that your calibration is due. They have the same type of alert system now on their system. So, yeah.
Mm-hmm. That's very beneficial. And then not only that, we have some cues, some user feedback right within the software where it would pop up yellow, would pop up red, depending on what needs to be addressed, how far out you are, or if it's coming due soon. And we're not just stopping there. If you recall, lighter, faster, stronger, as far as our ideals. The Mini, if you harken back to the legacy, is we like to refer to the old back rack system, where you could have maybe 8 CFM in a very similar package, which Sean has one of these too. So if you guys would like a demonstration, we can bring one to you. We can hit 15 CFM with this. Our standard unit's 35, and as I mentioned before, you could look at 300 CFM. So we're really innovating, we're driving, and we're very excited about that. So, and we're not just stopping there. I know a lot of you guys here are utilities, and we're very excited to work with Heath on a bar hole testing application. So new that we're not showing you the sketch yet. but again, lighter, faster, stronger, if you can think of that. Self-contained, higher accuracy than what you have now. Ease of use. It's going to meet PHMSA as far as requirements with that. And it's going to be a more efficient way of pinpointing. So we're very excited about that. It's to us, coming from automotive and taking, that type of methodology of making things lighter, faster, stronger, and more ruggedized, and bringing it into oil and gas and working with Heath. I just think it really speaks to that. So we're gaining the industry knowledge and the day-to-day use with Heath and applying, the technology and application to that. So with that, we'll take questions. Thank you.
The Hi-Flow 2 sampler. Let's say I have a client, I'm using it on the field, and the client wants me to verify the sample flow rate. Can I do that out in the field? And if so, how would you recommend I do it?
Well, you'd have to have a reference point to do that. But we have it does have a certificate that it's working.
Client wants independent verification. I've run across this before.
Okay. I'm going to leave that one to Manny.
I used a hot wire anemometer, but I don't know if that's the best thing to use in this case.
Independent verification of flow?
Yes, sir.
Okay. Well, you do have the certification, the calibration to fall back on.
Well, what about the flow meter you're testing it on? It's got to be certified as well. It kind of is a
True. Yes.
Yeah.
Yeah.
So there's one.
They wanted it checked every day.
Every day.
Every day of testing.
Okay.
That is interesting.
I haven't heard that one before.
This was
Yeah,
a state
me either.
agency.
Okay. On the flow meter or the analyzer?
It was the old Hi-Flow sampler, and every day I used it, they wanted it verified what the flow actually was.
Is that in the regulation?
No.
Okay.
The old one.
Yeah, the old one. And I'm just wondering if you could do it with the new one.
That's the new one. Yeah.
Yeah.
Every day on the flow meter. Okay.
Yeah.
Right now, EPA, the Quad OB is saying once a year is fine. That's interesting. So,
Yeah.
yeah. There's a lot of regulations.
Good.
One last question, ergonomics. If I'm using this all day, am I going to have back pain, shoulder pains, knee pains?
That's the lightest thing out there for what it's doing, but
For this level of accuracy, yes, it is the lightest out there. So, but the question is, what exactly are you doing? Because if
Yeah.
you are looking at a pipeline application that you can, I hate to say get away, but it's size-wise, if you can limit to 15 CFM, I would use the Mini. And it's every bit as light, if not lighter, than the legacy of what you had out there,
Okay.
with twice the flow.
I'm sorry, I have one more question.
No, absolutely. I
At a
love it.
really high flow, aren't you worried that you might be exaggerating the leak, that you're actually causing something to leak? No?
no. No, that's actually, I'll give you an example just to answer that a little bit. So we're doing a lot of work with the DOE on measuring orphan wells, and some of these orphan wells aspirate and breathe naturally. So it depends on the leak itself, really. But once you get everything hooked up and you start sampling, the leak will stabilize itself once you start pulling from it. You might get a sudden spike or something like that,
Yeah.
but you'll see it stabilize out. You just got to watch for that. And, you're measuring for stability. A lot of people say, how long do I measure a leak for? And I say it really just depends on the leak and what you're doing. If you're, it could be a 1 minute measurement, if it's just a very easy, stable leak, or, if it's rod packing or something. Quad OB actually wants you to do 3 separate tests and then combine the 3 tests to compare and make sure that all the tests look in alignment. But the goal is stability. You want leak stability. So once you are able to get a stabilized leak rate and characterize that, and you're getting second by second data logging, so you're able to really see good resolution of that leak. We used to just kind of get just a quick snapshot, and it was much harder to characterize leaks with some of the legacy technology. But yeah.
Yeah, and you also have the benefit of the bench being a TDLAS. So you're less likely to oversaturate that as a sensor compared to some of the older technology that you had to worry about that with.
Okay, thank you, gentlemen.